Dr. Birgitta Norberg from the Institute of Marine Research will give the presentation.
Yes, so Atlantic halibut was chosen in the DIVERSIFY project as the cold water species example. And the reasons, of course, are that halibut are large, they have a high price, fisheries have declined, and we have tried since the 1980s to build a commercial aquaculture of Atlantic halibut. There was a lot of optimism and a lot of money put into this in the 1980s, 1990s. We had a stagnation after that, and Atlantic cod production increased very, very rapidly and then collapsed again, probably, or it collapsed due to disease problems that were not solved. It collapsed due to the wild stocks catching up and wild cod becoming more available, and also the financial situation around 2008, the financial crisis. Possibly cod production grew too rapidly. During this time, the interest for Atlantic halibut was kind of low, but there were some enthusiasts that were going on, that kept the activity going, and they don't give up. And we worked together with them. So slowly and steadily, Atlantic halibut came back up and is now growing quite well. Not fast, but the development is very, very positive. I'll come back to that. So we defined for this project the major bottlenecks. We wanted to focus on juvenile production because that was a very major bottleneck. Availability of juveniles for on-growing was very limited and very unpredictable, very unstable, varied a lot from year to year. So we defined bottlenecks within broodstock management, larval husbandry, and especially survival and development through the early stages, nutrition also during the early stages. And then we were also asked, actually, when we got the project, we hadn't included first, but we were asked to address the problem with viral infections during early development, and more specifically to try and develop a vaccine against the VNN caused by notavirus. So I'll just go through these bottlenecks one by one. Broodstock management. The bottleneck there is still that you have an unreliable and somewhat unstable supply of really high quality eggs. We know how to do it, but that's really labor intensive. So with big stocks, a lot of eggs just go to waste. We also had a hypothesis here that the farm broodstock of first generations, F1, F2, had an inferior spawning performance performed to wild captured fish. So the approach here was first to document the performance of farmed and wild captured fish, our fish, and then also to see if we could get these farmed females to produce better and more eggs using hormone therapy, GnRH implants. I'll just go very quickly through this. We got some results. We could see that the egg viability, the fertilization rates in farmed females was lower. We could also see that they had somewhat smaller eggs. The difference is not big, but it is significant. Hatching rates, when we compared that specifically, we could see that a lower proportion of the eggs from the farmed females hatched. They were heavier, had a higher density, and this caused mechanical damage. So here you can see larvae from wild captured fish. Most of them look really nice, newly hatched, while the farmed females, you could see they were at the bottom, and you think that caused mechanical damage, but also caused a lot of maldeformed newly hatched larvae and higher mortalities. We did an experiment where we looked at the effect of GnRH implantation. So we had more eggs from the implanted females. They started mostly spawning earlier. One of the control females were too close to maturation, so it matured anyway. But the fertilization rates, the viability was really, really variable. We got a few good batches, but we had shorter intervals between spawnings, and we got generally lower egg quality. So over to larval husbandry. survival through early life stages has been one of the really major bottlenecks for halibut production. And I will now just address one of the things we did, and that was to look into the RUS, the recirculation systems, to see if this is a better rearing system, if we can improve survival, growth, development by using recirculation, and that way create a more stable system where you also have a bacterial community that will have a probiotic effect. So we did this, we documented survival, development and growth, and we also performed a metagenomic analysis of the bacterial composition. So during first feeding we used a standard system. Here is the recirculatory system, standard larval rearing tanks with collars so that you have a shade where the larvae will be when they feed. We had turbidity in the water using clay suspension, so we had grey water. And also we need to mention that we have expert technicians, so I need to mention Ragnfrid here because she dedicates very much of her waking hours during the season to running these first feeding systems. So directly to the results, you can see here that with proper priming, growth in the recircular system in red here increased compared to the flow-through system. We have big variations. Survival was stable in the tanks. 45 to 50% is what we get in the good halibut rearing systems, and we routinely get more than 35%. So it's not too bad. It could be better, but not too bad. What we also saw here is that the flow-through system is less stable, and one of the tanks just crashed, and that happens with the flow-through systems. So we also did a metagenomic analysis, sampled water and larvae in both yolk sac and first feeding stages. I skipped the yolk sac stage here because the results were the RUS and flow-through systems were very similar, no big difference, so I just focused on the first feeding. We used MySeq, Illumina sequencing technique, and by that we could show that there were significant differences between those systems, and which can be important or will be important if we want to develop a functional probiotic treatment to find the right strains to add to the water that will help the larvae and stabilize the system. So with nutrition, the bottleneck here is that the larval stages for halibut last very long. So the yolk sac stage lasts for a month, and then the first feeding period is for 70 days, so it's over 2 months. The larvae are large, they feed on Artemia straight away, no use of rotifers. But these Artemia will be gradually relatively smaller as the larvae grow, and there's been some discussion whether they have the right nutrient compositions throughout the whole development. And also it's quite labor intensive to produce large amounts of Artemia or live feed. So we tried 2 strategies here. On growing the Artemia so that it would become larger and have a better nutrient composition, or try to wean them earlier to formulated feed. So instead of 70 days, maybe 3 or 4 weeks, and even earlier than that. So that's what we did. We grew Artemia, fed them to halibut larvae, and we tested different formulated feeds, 15, 28 and 28 days after start of first feeding. So to look at the early weaning first, we got large differences in larval response to the different feeds, where the Autohemi feed came out on top. We saw also that the larvae would take the feed and survive from 28 days post first feeding, but not before. It still is quite a big improvement. So the choice of feed is important. You can feed them at least from 28 days post first feeding. And we must test the effect on growth, survival and juvenile quality. And also what we're doing now is to transfer the results from these small systems, 70-liter system, to full-scale first feeding tanks which are 1.5 meter in diameter and hold much more larvae and larger systems. Then the ongrown Artemia. Earlier work done in mainly 1990s and early 2000s showed that ongrown Artemia improved juvenile quality in halibut. You could see, yeah. However, when we did this again, we could grow the Artemia quite well. We had improvements in nutrient composition, more protein, less lipid, less glycogen, etc. But we couldn't see any effect really of the ongrown Artemia on the development of the llamas. So our conclusion here is that things have changed and we have learned more since in the last 20 years basically. So the modern diets we use for rearing Atlantic halibut and the new rearing methods that we have developed make these Artemia nuclei a sufficient larval diet anyway. So we don't really need to put a lot of effort into growing Artemia. So finally, fish health. This has also been a really tough question to solve. High mortality in some groups due to viral infections during first feeding. We had a hypothesis that we could develop an oral vaccine and deliver them to larvae through incubation in the live feed. So we expressed the capsid proteins of the norovirus in different systems, delivered them to Artemia, then we fed these to larvae and assessed the immune response. Just showing you the viral diseases here, because what we also found out outside of this project and independent of DIVERSIFY, a new virus was identified, the aquareovirus, ARV. And this is likely the major cause of mortalities during early stages of Atlantic halibut. Probably much more so than the Noda virus that we suspected previously. So to assess the vaccine, we produced the antigen expressed in E. coli, in a protozoan Leishmania, another protozoan Pichia, and tobacco leaves. Then delivered to Artemia, fed them to larvae and challenged them with the virus. We could see, these are nice pictures, so we could see that in both E. coli and Leishmania the protein was expressed. You can see here tagged fluorescence and overlay. You can see that the Artemia fed on this very nicely and that it was taken up very well in the Artemia. However, this shows that they ate it, but they also had a quite rapid breakdown. So you have to work fast if you want to be able to feed it to the larvae. This was the trial, same system as the early weaning. First of all, our rigs with 70-liter tanks. We delivered them to larvae. We also had controls that were injected, larger controls that were injected. But we didn't really see very much protection here. This is just showing the weight and the CT values showing that there is not a very big effect of the vaccine actually. So we had some notes here from lab trials. We can't initiate them before 100 days post-hatch. The immune system isn't developed. Could be important to have a balanced diet during development, and we also need to work on best practice and hygiene during early phases. And anyway, both the E. coli and Leishmania expressed proteins were filtered from seawater and taken up by the Artemia. So to go on and conclude this now, the impact, Dinos wanted me to say what the impact on the industry has been. Overall, during this period, Atlantic halibut has had a very positive development. The production is growing by 10-15% per year of halibut to the market. There is also, as I said, a very strong requirement for stable and predictable availability of juveniles of high quality. So the general knowledge and better knowledge we have on broodstock management will improve output of gametes. One important thing is the trials we're doing on recirculation in larviculture, but also on later stages. I'll come back to that. We know that we don't need to grow Artemia more than we do. We will continue to work on viral infections, vaccine development. So, finally, the new bottlenecks, further challenges. We still struggle with gamete quality. It is an eternal question. It's been, I've been working with halibut since 1986, and egg quality has always been a question. And finding good, reliable, and not least affordable markers is important. Also, to improve stability and performance, both in the farm fish, but also in the out-of-season breeders. And then to move on to breeding and breeding programs, to select the right individuals. And outside of DIVERSIFY, we have sequenced, assembled, and annotated the halibut genome. So we now have a very good tool to find markers for desirable traits. And the larval husbandry, we still need to, 45% through first feeding is maybe not bad, but we need to increase it even more. And also improve the development from egg to juvenile. So to improve the general quality. Optimize use of recirculation during early life stages can be important. Improve the stability in first feeding tank. Also continue to work. Some farmers still struggle with poor eye migration and pigmentation. So we need to improve that too. A general improvement in quality and quantity, basically. For nutrition, we will continue working on early weaning on larvae to decrease the dependence on live feed and optimize the nutrient composition. Another thing that we haven't addressed at all in DIVERSIFY is the ongrowing phase. We need to move on to that now because the availability of juveniles is so much better, and we need to look into sustainable feed development for ongrowing using new feed ingredients. To increase growth during the first year of life, we did that. In the 1990s, we managed to grow halibut juveniles up to 500-600 grams in 1 year after first feeding. So we know it's possible, but we need to improve the routines. We need to improve growth to have a larger fish to put, so we can put them earlier in the sea cages. Right, Trond? Yeah. So again, use of recirculation can be one way of improving environment. We need to avoid early maturation still, even though we now have mostly an all-female production. I know that some of these fast growers can also, even the females can go into maturation too early, so we need to avoid that. With health, told you about the ARV and the discovery of that was a major breakthrough actually to stabilize juvenile production. And we know, one thing we know for sure is that when we start producing new fish species and the production increases, new diseases that we don't know about will occur. So we need to be aware, we need to detect and screen the pathogens to see that we are always one step ahead. It's difficult, but we need to know that. We need to work more on the maternally transmitted viral diseases like ARV, and also parasite treatment, which is mainly done with formaldehyde, which is very difficult to get hold of. Then I also included a point on branding and marketing and sales, but I spoke with Magnus Skretting, who is the CEO, and said we definitely need to continue making an effort there. So, not there. So I think this is most of this. We had a workshop too. It was really successful. Dinos can vouch for that. And to what we were talking about with Pascal. The farmers came, they were really open with everything, when everyone presented their results, and I think there was a very, very good discussion. And again, they also want to have these workshops every year, so we'll see what we can do. Yes, thank you.
Thank you, Birgitta. Well, it's a good opportunity to try to keep them together now, and maybe both now that our results are going to be published and it will be more formalized, we can maintain our dissemination. Of course, our website will remain open and it will be a source of information. We can produce some more popularized text for them, and then also based on your national funding and other funding, you can use this initial opportunity to keep them together for the next few years, like with the pike perch, and hopefully new projects will come up and new knowledge will become available for them. So questions for Birgitta?
I have one.
Yes.
Birgitta,
Yeah.
do you have the chance to have this good bacteria that were giving such a good results in your circulation system and inoculate another
Not yet. So we will continue this work, but the sequencing and bioinformatics characterization is quite. It looks. I didn't show it, but that's quite a huge task actually. So the first step is to really see what is in there, and then try to see what has an effect, what's not important. But it is a very important first step to characterize and see which bacteria are present. And there were very big difference between the recirculatory systems and the flow-through systems.
But it's likely that maybe if you repeat it on time, the microbial community that you will have in your RAS is going to be different, and maybe you will not be affected by your inoculum. I don't know.
Well, we don't know. We need to try that. So yeah.
Okay.
Another question?
Björn.
Yes, Björn.
I just have a few questions and comments.
Yes,
and that
yes.
is, one, I wonder if you have tried with copepods from CP on the halibut. I know others have tried. And second, and the other thing, I would just support the view you have that I've been involved a bit in turtle farming, as was
we know
I
that.
was on the board of one of these companies for a period, and I have to say I'm glad to hear they now work together, because just a few years ago they didn't talk together. They were competitors both on the market and also in competition, and with the 10% to 15% growth per year is impressive, but it comes from a very low base. It's only 1,500 tons being produced after maybe 30 years of research and development. So this is really taking a lot of time and effort. And one of the problems, I think, is the cold water we have in Norway. I totally agree with you, Birgitta. We can keep them for the first year in recirculation. That could reduce the growing period from maybe 3, 4, 5 years to maybe at least with 1 year.
Yep.
So I'm sure that's the way forward. But the industry is very slow on adapting to that.
Yes. First, I'll answer your question first. Yes, we did an initial experiment with copepods together with Ingvar Tramadal and Sintef in Trondheim. At that time, they didn't really work too well on halibut, so we have been continuing to using Artemia. But of course, it's interesting. Then to your comments, yes, it is a slow growth, but we see now that the development, I mean, part of the reason is that the juvenile availability has been so low. There are very few farmers, and I was also very glad to see that the good communication that exists now. And I think, as you say, with improved growth during the first year, and also which we haven't addressed very much here, because we had already started it before Diversify. Most of the production now is all female, which will also lead to a leap in growth, because what were you saying, Bertrand? About 80% of the slaughter fish below 5 kilos have been mature males.
Yes.
So we're rid of them now, which will also improve the results. But I think, I really think that the period up to you put them in sea cages is important, and it's very important now to work on increasing the growth there. Do you have a comment, Trond? You can say something.
I suppose so. That's right. The good thing is the farmers start talking together. That's fantastic. I think that's a good beginning, because to have this increased in the development, we need to talk together. The production is growing and increasing even more than 10 to 50% per year. Only our company can produce more than 1 million juveniles, and it's no problem to put all this fish into sea and increase the production even more. As you said, to have this period up to 500 grams as short as possible, that's very important. So the main thing is to have a growth, and also the first year, but also after during the sea period. So.
I guess what I understood from the workshop was that the potential for growth is there. I mean, the knowledge for more growth, more production is there, but the companies didn't want to increase too rapidly. They want to do it hand in hand with the market so that they will maintain the high price. So increasing the production is not so much, well, to a certain extent, I don't know to what extent, but it's not so much on the lack of technology or the lack of success, but it's mainly not to go too high and lose the market price. This is what I understood.
That's one important issue as well, and that's part of the reason why I took the example of cod, because that grew from practically nothing to 25,000 tons in just a few years, and then it just collapsed. So it can be a better strategy to just increase a bit slower and develop a market at the same time. But it's also a question of shortening the time to reduce the production costs, of course.
Yeah.
Yes, that's right. But I think it's good for the industry to keep going the good work with the marketing and branding and learning in the middle of Europe as well. Halibut is not that good known fish in the worldwide, but you have some large good market in UK and US, but I think we have a job to do in the middle of Europe actually.
Yeah.
Based on its taste, you're not going to have any problem convincing them.
Yeah,
I'm a believer.
Yeah, Innos was he was converted.
Yeah,
he was
sure.
Convinced.
Yeah, for sure.
But yes, we will start that at lunch, I think, in half an hour. So.
Yeah. Good.
Yeah.
Okay, thank you very much, Birgitta.